Welcome to the deep dive. Ever looked at a teenager and just thought, what is going on in there? Well, today we're diving deep into the science behind the teenage brain. It's pretty fascinating stuff.
It really is.
Turns out adolescence isn't just, awkward growth spurts and social drama. It's actually a huge period of brain transformation.
Exactly. We need to ditch the idea that a teen brain is just a mini adult brain. It's really not.
Right.
What's actually happening is more like a major reengineering project, a kind of second wiring phase.
A second wiring, I like.
Yeah. And we've pulled together insights from Science News, Brain Facts, that's from the Society for Neuroscience,
Okay.
the NIMH, CDC, and also Time Magazine, just to try and give you a really clear picture of this, well, critical stage.
So our mission today is basically to unpack the big questions, right? Like, what is this rewiring? Why do teens sometimes seem, so impulsive or have these massive emotional swings?
Yeah, the moodiness question.
Totally. And crucially, what can parents, or really anyone who cares about teens, do to support healthy brain development during this time?
Right. Practical takeaways.
Exactly. So if you're trying to understand the teenage mind a bit better, maybe you're a parent, a teacher, maybe you are a teenager,
Yes.
then you are definitely in the right place. Okay, let's get into it. This second workshop idea for the brain sounds like serious construction.
It really is a period of intense activity. The teenage brain, it's not finished, not by a long shot. It's being actively refined.
Refined how?
Well, there are two key processes happening: synaptic pruning and myelination.
Okay, break those down for us. Synaptic pruning. Sounds like gardening.
It kind of is, actually. Think of it as the brain becoming more specialized. You know, all those connections between brain cells, the synapses that formed like crazy in childhood?
Yeah.
Well, during adolescence, the brain starts evaluating them, and the ones that aren't used very often, they get trimmed back.
So use it or lose it, basically.
Okay. Pretty much. It's like the brain focuses its energy on the pathways that get used the most. Like a path in a forest getting clearer the more you walk on it.
Okay, that makes sense. Efficiency.
Exactly. It's crucial for developing more complex thinking later on.
So it's not just about getting rid of stuff. It's about making the brain better at what it does keep.
Precisely.
Got it. And the second one, myelination.
Right. Myelination. Think of this as upgrading the brain's infrastructure.
Okay.
It's where the nerve fibers, the pathways that signals travel along, get wrapped in this fatty substance called myelin.
Like insulation on a wire.
Exactly like insulation. And that insulation makes the signals travel much, much faster. It speeds up communication between different parts of the brain.
So faster connections, more efficient processing overall.
You got it. Makes the whole system work better.
Less buffering, faster downloads in the brain. A major system upgrade.
That's a good way to put it.
But you mentioned earlier, this upgrade doesn't happen everywhere at once.
No, definitely not. The brain's maturation timeline is quite staggered. We call it asynchronous development.
Asynchronous, meaning out of sync.
Yeah. Different parts mature at different speeds. Generally speaking, the back of the brain tends to develop faster than the front.
And the back is more about
Emotions, memories, processing sensory input. That area gets up to speed relatively earlier.
okay, and the front. That's where the more logical stuff happens. Planning, decision-making.
Exactly right. The prefrontal cortex. It sits right behind your forehead.
Mhm.
And it's responsible for all those executive functions: planning ahead, judgment, self-control, thinking about consequences.
The brain's CEO, kind of.
Sort of, yeah. And this CEO is one of the last areas to fully mature. We're talking well into the mid to late 20s.
Mid to late 20s, wow.
Yeah, and some research even suggests parts might still be developing up to around age 30.
That is way longer than I think most people realize. So, okay, when we see teens sometimes acting impulsively or maybe not fully grasping the risks, is that partly because their prefrontal cortex, their control center, is still like under construction?
That's a really key insight, yes. That region is still developing its full capacity,
Right.
which can definitely contribute to impulsivity, maybe shorter attention spans, and just a different way of evaluating risks compared to how an adult brain might do it.
So it's not that they can't think logically.
Not at all. They absolutely can, but the brain region needed to consistently apply that logic, especially in the heat of the moment or when social factors are involved, is still maturing.
Okay. And maybe this period where the stakes aren't always super high allows for some learning through mistakes.
Well, yes, that exploration is actually crucial for developing good judgment eventually. It's part of the process.
Now, something else our sources highlighted was plasticity. The teen brain isn't just being built, it's incredibly adaptable.
Oh, absolutely. Hugely adaptable. Adolescence is a period of really heightened neuroplasticity.
Neuroplasticity.
Yeah.
The brain's ability to change itself.
Exactly. Its amazing ability to physically rewire itself based on new experiences, tackling challenging mental tasks like puzzles, learning music, coding,
Yeah.
creative activities. All of these things literally strengthen the neural circuits that are being used.
So if a teenager gets really into, I don't know, learning guitar, they're not just learning chords, they're actually building stronger connections in their brain related to music and motor skills.
Precisely. Think of it like exercising a muscle.
Right.
The more you use those specific brain pathways, the stronger and more efficient they become.
Which makes adolescence a really critical window for learning that.
A massive window of opportunity, yes. The brain is just so receptive to new input and can adapt so readily during these years.
Fascinating. And linked to that, the brain's focus seems to shift too. I remember the Science News article mentioned a study, something about voices.
Ah, yes. The study showing that teenagers' brains start showing a stronger reward response to unfamiliar voices compared to their own mother's voice.
Yeah. That sounds, well, kind of dramatic. Maybe a bit sad for moms.
Huh. It might seem that way on the surface. But if you think about what's happening in a teen's life,
Their social world is expanding.
massively, beyond the family. They need to navigate relationships with peers, figure out social cues from lots of different people, build their own identity outside the home.
Okay.
So becoming more attuned to unfamiliar voices and social signals is actually really important for developing independence.
So it's not that they stop caring about their parents' voices,
Not at all. That connection is still there.
but their brain is becoming more interested, maybe more rewarded, by social information from the wider world.
Yeah.
Like it's adapting to navigate that new landscape.
Exactly. The brain's adapting to the teenager's changing social needs. It's becoming more sensitive to the voices and dynamics that are increasingly important for figuring out their place in the world.
But that heightened sensitivity,
Yeah.
could that also make them more susceptible to, say, peer pressure? If those social connections feel so rewarding,
That's definitely part of the picture, yes. That increased reward associated with peer interactions can sometimes influence decision-making.
which brings us back to emotions and risk-taking. This intense brain development seems tied into that too, right? Like that mismatch you mentioned.
Yes, it ties right back to that asynchronous development. The emotional centers like the amygdala involved in processing fear and pleasure, they tend to mature and become more active earlier in adolescence.
Okay.
But the prefrontal cortex, the part that helps regulate those emotions and make reasoned judgments, is still playing catch-up.
So you've got this gap.
Exactly, a developmental gap. And that can sometimes lead to more intense emotional reactions and, yes, potentially an increased tendency towards risk-taking behavior.
Is that where that feeling of like invincibility comes from sometimes?
Yeah.
Or the urge to push boundaries? Is it the emotional gas pedal being stronger than the rational brakes?
That's actually a pretty good analogy. The drive for new experiences, for social connection, that's strong. And sometimes the potential social rewards of doing something risky might just loom larger in a teen's mind than the potential negative consequences.
Because the prefrontal cortex isn't fully equipped yet to weigh those consequences like an adult brain might.
Right. Or it gets overridden by the emotional or social drive in the moment.
It's important to remember, though, like the sources said, not all risk-taking is bad, is it?
Absolutely not. That's a crucial point.
It can drive them to try new sports, make new friends, apply for that challenging program.
Precisely. That drive for novelty and pushing boundaries, while it can lead to concerning behaviors, is also fundamentally what helps teenagers explore, learn about themselves, and develop their own identities. It's really a double-edged sword.
Okay, let's shift gears slightly to something with, well, clearer downsides. Substance use.
All right.
Given everything we've said about plasticity and ongoing development, this sounds like a particularly vulnerable time.
It is a very significant concern. The brain's adaptability, its plasticity, which is so great for learning, also makes it more vulnerable to the negative and potentially long-lasting effects of drugs and alcohol.
How so?
Well, frequent substance use during this critical period can actually disrupt normal brain development. It can damage areas crucial for memory, attention, and those executive functions we keep talking about.
The prefrontal cortex stuff?
Exactly, the very things the brain is working so hard to refine.
I remember reading in the BrainFacts resources that teens who drink heavily might actually have less gray matter and maybe weaker white matter connections.
That's right. less gray matter, the processing centers, and less robust white matter, which affects that crucial communication speed we talked about with myelination.
Wow. That sounds like it could have really serious long-term impacts on how their brain functions.
It absolutely can.
Mm.
And studies using fMRI, those brain scans that show activity, they've indicated things like lower overall brain activity, more difficulty sustaining attention in adolescents who binge drink. And they tend to perform worse on tests of working memory.
Working memory, like holding information in your head to use it.
Yes, crucial for learning and problem solving. And what's really concerning is that the brain regions involved in addiction actually overlap significantly with those needed for learning, memory, and reasoning.
So using substances can directly interfere with the brain's ability to learn and think clearly, right when it's supposed to be getting better at those things.
Exactly. It hits those developing systems hard.
So it's not just about the immediate risks of being drunk or high. It's about potentially altering the brain's structure and function for the long haul.
Precisely. And because that prefrontal cortex is still maturing well into the 20s,
Right.
any disruption during the teen years can have really significant lasting effects on things like planning, organization, impulse control, skills needed for adult life.
Okay, this is all incredibly important context. So knowing all this, the rewiring, the timing mismatches, the plasticity, the vulnerabilities, what can we actually do? What helps support healthy brain development during these years?
Yeah, the practical side. Well, our sources were pretty consistent on several key areas. First up, and maybe the most fundamental, sleep.
Sleep. Always important, but especially for teens.
Absolutely critical. The National Institute of Mental Health, the CDC, they all recommend around 8 to 10 hours of sleep per night for teenagers.
8 to 10. Seems like a lot in today's world.
It is, and it's often hard to achieve. But sleep isn't just about not feeling tired. It's crucial for brain function, for consolidating memories, for learning, even for regulating emotions.
Which, as we've discussed, can be a challenge for teens anyway. So sleep helps stabilize things.
It really does. Prioritizing consistent sleep routines is vital.
Okay, what else?
Nutrition. Can't overlook that.
Fuel for the brain.
Exactly. The CDC emphasizes healthy eating patterns, lots of fruits, vegetables, whole grains, lean protein, giving the brain the building blocks it needs to grow and function optimally.
Makes sense. Garbage in, garbage out applies to brain food too.
A simple way to put it, but yeah, pretty accurate. Then there's physical activity.
Exercise, how does that help the brain?
In lots of ways. The CDC recommends at least 60 minutes of activity daily for teens. It's obviously good for physical health, but it also boosts cognitive function, improves mood, reduces stress, all great for overall brain well-being.
So getting them moving isn't just about sports, it's actually helping their brains work better.
Definitely. And tied into that is mental stimulation.
Keeping the brain active.
Yeah. Engaging in challenging cognitive tasks, remember the plasticity.
Right, strengthening those connections.
Exactly. Puzzles, learning an instrument, debate, coding, creative writing, art. Pursuing hobbies that require focus and problem solving really helps build those developing neural circuits.
Like that muscle analogy again, you got to work it out.
You do. The brain benefits from being actively engaged and challenged.
So encourage the interests, the passions, the things that make them think.
Precisely. And one last, maybe more subtle point, particularly for parents and caregivers, patience and curiosity.
Patience. Easier said than done sometimes.
True. But trying to understand why a behavior might be happening based on this brain science, can help. Instead of just focusing on rules or getting frustrated, try asking questions. Be curious about what they're learning, what they're thinking. Really listen.
So less, why did you do that? And more, what was going through your mind then?
Something like that. Remembering their brain is literally a work in progress, changing rapidly. They aren't usually trying to be difficult. It's often just the developmental stage.
Right. Trying to understand the underlying process rather than just reacting to the behavior, seeing it as evolution, not malfunction.
Beautifully put. Seeing the teen brain as dynamic, adaptable, full of potential, but also navigating these big shifts, it can really change how we interact with them.
Okay, so wrapping up our deep dive into the teenage brain, it's clear this is just a remarkably dynamic, totally crucial period of development.
Absolutely.
This whole second wiring phase, the pruning, the myelination, it really does provide a scientific basis for a lot of those behaviors that can seem, well, perplexing from the outside.
That's right. And the asynchronous development emotional center is firing on all cylinders, while the rational prefrontal cortex is still maturing. That helps explain some impulsivity, maybe some moodiness, the shifting social focus.
But crucially, it's also this time of incredible plasticity,
Hmm.
meaning the experiences, the learning, the challenges they face during these years literally shape the brain they'll have as adults.
Profoundly shape it, yes,
Right.
which is why support is so vital.
And that support comes down to some core things, making sure they get enough sleep, access to good nutrition, regular exercise, and opportunities for those mentally stimulating activity.
It's about nurturing this incredible period of growth and potential while understanding the unique challenges it presents.
Absolutely. And that leaves us and you, our listener, with a final thought to chew on.
Yeah, considering these really profound, rapid changes happening inside the teenage brain and its heightened ability to adapt and learn, how do you think the specific experiences and challenges someone encounters during their adolescence might shape their long-term cognitive abilities, maybe even their personality?
That's a big question.
It is. It's a stage that's just brimming with both potential vulnerabilities and incredible opportunities for growth. So, what role do you think we as a society, our communities, our support systems play in guiding and supporting teenagers through this really critical phase of human development? Definitely something we're thinking about.